Hi, welcome back. In this video, we're going to do a few more examples involving bases and dimension. So in our first example, we're looking at a subspace of R3 consisting of all the ordered triples of the form 2s minus t, comma, s plus t, comma, t, where s and t are real numbers. First of all, we're asked to find a basis for this subspace. A basis is going to be a set of linearly independent vectors such that any vector in W is a linear combination of them. It has to span W. So let's rewrite this arbitrary element of W. Let's rewrite it as a linear combination of two vectors in R3. So here's an arbitrary vector in W. First of all, I can write it as the sum of two vectors, one of them involving just the parameter s, and the other one just involving the parameter t. And then I can rewrite each of these two vectors as a scalar multiple of some vector in R3. So the first one is s times 2, 1, 0. The second one is just t times negative 1, 1, 1. So here I've rewritten an arbitrary element of W as a linear combination of two vectors in R3. Clearly I've found a set of two vectors that spans W, because anything in W is a linear combination of just these two vectors. And I can tell that the two vectors are linearly independent because in the first ordered triple, there's a 0 in the third component. But in the second ordered triple, there's a non-zero number in the third component. So there's no way we can write the first one as a scalar multiple of the second one. And so that means these are linearly independent ordered triples. So now we found a basis for W. So let's call it S. The basis S consists of the two vectors 2, 1, 0 and negative 1, 1, 1. Now that we've got a basis, we know what the dimension of W has to be, because the dimension of W is just the size of any basis, and we know any other basis for W will have to have only two elements in it. So the dimension of W is 2. Okay, so what's a geometric description of a two-dimensional subspace of R3? That's just a plane in R3. All right, let's do something somewhat similar in R4. So in this example, we have a subspace of R4 consisting of all ordered 4 tuples of the form s plus 4t, t, s, and then 2s minus t. Those are the 4 components of any ordered 4 tuple in W. Let's do the same thing. Let's find a basis for this subspace by rewriting an arbitrary 4 tuple in W as a linear combination of 4 tuples in R4. So let's take this arbitrary 4 tuple. First, write it as a sum of just 2 4 tuples, each one involving one of the parameters. So the first one just has the parameter s in it. The second one just has the parameter t. And now we can rewrite this sum as a linear combination of exactly 2 4 tuples from R4. So the first one is s times 1, 0, 1, 2. The second one is t times 4, 1, 0, negative 1. Now we've rewritten an arbitrary 4 tuple from W as a linear combination of 2 4 tuples from R4. So we have a set of 2 4 tuples from R4 that span W, and they're clearly linearly independent because one of them is not a scalar multiple of the other. There's no way we can write the first 4 tuple, because it has a non-zero entry in the third component. There's no way we can write that as a scalar multiple of the second one, because the second one has a 0 in the third component. So we have a set that's linearly independent. So we have a basis with just the 2 4 tuples, 1, 0, 1, 2, and 4, 1, 0, negative 1. Okay. And now the last example we're going to do is this one. It says find a basis for R2 that contains the vector 2, 2. So all we need is another vector in R2 that is not a scalar multiple of the vector 2, 2. Because, well, first of all, R2 is dimension 2. So we just need one more vector, and we want it to be linearly independent with this one. So let's just write down a basis that contains 2, 2 and just one other vector that's not a scalar multiple. So I chose 1, 0. So remember, a basis is not unique. It just has to have the right number of elements in it. So for R2, we have to have 2 vectors in our basis. They have to be linearly independent, and then they will span R2. All right, so that's it for these examples, and I'll see you in another video.